Today let's do relational operators. So first of all, let's understand what are relational operators. So relational operators are basically used to compare two values, right? So the first point is relational operators are used to compare two values, and the result of the relational operators is always logical, that is either true or false, right? The result of using a relational operator is always logical, that is either a true or false. True has got the value of 1 and false is represented by a 0, right? Okay, now let's see. Oh sorry, that's a 0 there. False is represented by a 0. Now let's see what are the relational operators in C++. So here I'll put it. Greater than, that is the greater than. Here we can write something like this: x greater than y. Then you have the greater than equal to operator. This is the greater than or equal to, which is x greater than equal to y. Less than operator, then you have less than or equal to. Then equal to, this is the equal to operator. We put two equal to signs in this, right? So this is basically for comparing the values. Like if you want to do something like this, x equal to y, that is we want to check if the value of x is equal to y, right? And then you have the not equal to operator. X not equal to y, like this, right? So I'll take up a small example just to show how the values will come. Let's take some values for x and y. Let x be equal to 18 and y be equal to 20, right? So if I write something like this, if you just write cout x greater than y, this is basically false, right? But here you will not get the answer as true or false, that is the output will not be true or false. Instead it will be shown like this: 0. X greater than y is false, that is a 0, right? Okay, now suppose we do something like this: x less than y, then it should give a true, fine, which is 1. If we have something like this: x plus 2 is greater than y minus 6, right? So now this is 18 plus 2, it will do first. 20 is greater than 20 minus 5 is 20, so 20 minus 6 is 14. 20 greater than 14 is true, so it should give me 1, like this, right? And x, cout x equal to y. This is again false because 18 is not equal to 20, right? So like this we can do: x plus 7 is equal to y plus 2, right? 18 plus 7 is 25, 20 plus 2 is 22, which is not equal, so again the result will be false, right? X not equal to y, this will give true because they are not equal, right? So this is how the relational operators work. So when we do proper questions and we learn the other things, then we will use the relational operators along with the other operators. Now let's understand what are logical operators. A logical operator is used to connect two relational operators, or I'll say two relational expressions or logical expressions. Here again, the result of such an operation is logical, that is either a true or a false. Now, what are the logical operators we have here? This is the logical operator. It stands for AND, right? I can write something like this: x greater than 10 and y greater than 20. I have connected two relational expressions, right? Then the next one is OR. OR is represented by this. Here again see, x not equal to 9 or y equal to 8, something like this, right? And then you have the negation operators. This is logical NOT. This is the NOT, right? NOT means it will just negate it. That is, if like suppose I'll put it like this: x equal to 8, right? And let's say if the value of x is 8, right? If the value of x is 8, then x equal to 8 will give what? X equal to 8 will give true, right? So not true means it is a false, right? So not basically does what? It changes true into false and false into true, right? Now let's look at some of the rules of the logical operators. The first one, the output of a logical AND operation is true if both the operands are true. Even if one is false, the whole expression is false. The second one, the output of a logical OR operation is false if both of its operands are false. It is the result, the output is true even if one of the operand is true, right? Third one, the logical NOT is a unary operator. It negates the value of the operand. Okay. Now suppose we have something like this: x is equal to 8 and y is equal to 10, right? Now if I write a statement like this: x less than 7, right? Let me put this in brackets like this: x less than 7 and y equal to 10. Now here you see, x less than 7, 8 less than 7 is what? 8 less than 7 is false. So it becomes like this: false and true. False and true, the result is false, because if you have an AND operator, then both should be true. The truth table of this I'll show you. True for AND operator, okay? For AND operator, you have two expressions, true and true. The result will be true. The result will be true, right? and if it's a true and false, the result will be false. If it's a false and true, then again the result will be false, and if both are false, then the result again will be false, right? This is the truth table. You can also say, I mean, it can also be put like this: 1 and 1, the result is 1. 1 and 0, the result is 0. 0 and 1, the result is 0. And 0 and 0, the result is 0, right? So this is basically what we have seen here. Both of them should be true, so that the result should be true. If one is false, the result will be false. Now let's take the same values again. X is equal to 8 and y is equal to 10. Y is equal to 10. Now if I write something like this, x greater than or equal to 8 and y less than or equal to 10, right? So x greater than or equal to 8 is true, fine. You have and here, and y less than or equal to 10 is also true, so the result will be true like this, right? Now let's see the logical OR. In a logical OR, the truth table is like this: true or true, right? That is true, fine. True or false is also a true. Even if one of them is true, the result is true, right? False or true. False or true is also true, and if both are false, then obviously the result will be false, right? This is this one is the first expression, this is the second expression, this is the result, right? Now the same question, x is equal to 9, let's take up y is equal to 11. If you have something like this, x greater than 9 or y less than 13, right? Now x greater than 9 is false. It's equal to 9, it's not greater than 9, right? Or y less than 13, this is true, so the result is true, right? Okay, same way if I do x greater than, or let's say x equal to 9 or y equal to 12. Now here this is true and this is false, but since you have a OR operator in between, the result is true like this, right? Obviously if both are true, the result will be true, and if both are false, the result will be false. So this is the logical OR, and these are the two things. As far as the NOT operator is concerned, it just reverses the result, that is true becomes false and false becomes true, right? Now I'll show you one thing here. Supposing you have x is equal to 10 and let's say y is equal to 15, and I have this expression, not x equal to 10 or y equal to 15. Now what is x equal to 10? X equal to 10 is true, right? But since we have a not before that, not true is false. False or y is equal to 15 is true. So this is, the answer is true. This not operator has got a higher precedence. Not operator has a higher precedence than the OR operator. So this not x is equal to 10, this will be done first, and then this part will be done. So you should not do it like x is equal to 10 or y is equal to 15 and then put the not operator. That is wrong. So first of all we have to do this part, that is not x is equal to, this part will be done first, not x is equal to 10. So whatever is the result of this, that is false, false, or y is equal to 15. It's like this, right? So this is how the logical operators and the relational operators work. So with that I come to the end of this session. Next session I'll take up some more operators and we'll take up some examples on these operators.